Today's video is on solving linear equations and inequalities, and largely this is kind of brushing up on our skills learned in Algebra 1. The goal of this is to gather all of your like terms together and solve for the variable. So we'll start off by simplifying the left side, combining your like terms. Then you do the same thing to the right. Then we'll gather the variable terms to one side of the equation and non-variables to the other, and solve for the variable, usually through division. It should be noted that if you ever arrive at a false sentence like 1 equals 2, then there is no solution to the linear equation. And if you arrive at a true sentence like 5 equals 5, then the solution is all real numbers. Finally, if our expression is an inequality, I want my students to express their solution in interval notation. So let's dive into example 1. Okay. In the first step, I distributed the 2 into the parentheses set on the left and the negative 2 into the parentheses set on the right. Notice a negative times negative equals positive. Then I gathered the like terms on the left to give me 2x plus 8, and the like terms on the right to give me 6x minus 10. Subtract 6x to the left and subtract 8 to the right, and I get negative 4x equals negative 18, and then divide both sides by negative 4. We arrive at a single solution of 9 halves. Okay. Example 2. This is an inequality. This inequality, we start off by distributing the 5 and the 2. That gets rid of all the parenthesis sets. Then we're going to gather our like terms. 20 and negative 9 give me positive 11. Gather the x's together on the right, and the 10 and the negative 12. We get this. Add 9x to both sides, and we finish with the inequality x is greater than 13 over 24. Sorry, negative 13 over 24. Because we divided both sides by a positive number, the inequality did not change directions. And this would be all numbers from negative 13/24 up to infinity. Both of these get soft parentheses because infinity is not a number. It will always have soft parentheses. And we did not include the equality, so this gets parentheses, not brackets. Example 3. Same process, we're going to distribute the 4 to get rid of that first parenthesis set, and distribute the negative 5 to get rid of the second parenthesis set. Then we will gather our like terms together, 12x and negative 10x. And we arrive at a true sentence. 2x minus 5 equals 2x minus 5. Oftentimes I see my students take it a bit further and they get to something like negative 5 equals negative 5, or even 0 equals 0. At any point where you have the same thing on both sides of the equal sign, you have a true sentence and you can jump to the answer of all real numbers, which can be expressed as the set double-backed R, all real numbers, the words, all real numbers, or interval notation, negative infinity to positive infinity. Okay. Example 4. Distribute the negative 2 into the parentheses set and the negative 6 into the parentheses set, noting that two negatives make a positive, so that negative 2 times negative 5 is positive 10, and negative 6 times negative 3x is positive 18x. Then we'll gather the like terms on each side, subtract 18x to the left and subtract 24 to the right, and we get negative 20x is greater than negative 63. Then I divided both sides by negative 20. Because I was dividing by a negative number, the inequality needs to change directions. And I'm looking for all numbers smaller than 63 over 20. So we go from negative infinity up to 63 over 20. We put a hard bracket on the expression because the equality is included here, so we want to include that number 63 over 20. Okay, let's look at example 5. Example 5. Distribute the -6 and the -3. Then we gather our like terms on each side. And we notice that the adding of 15x to both sides creates the sentence -33 equals -11. And that's a false sentence. Anytime I encounter a false sentence, I draw a line through it so that I'm not writing anything that's true. It's my way of signaling, hey, that's odd, that's a false sentence. False sentences generate the answer, no solution. Example number 6. Got an inequality here. Distribute and distribute. This takes away the parenthesis sets. Then we'll gather our like terms on the left. X minus 5x is -4x. And on the right, 6x minus 5x is positive x. We'll gather the x terms to the left-hand side and the non-x terms to the right-hand side. And again, we've encountered a division by a negative number, so the inequality needs to change directions. My solution is x is greater than or equal to 8/5. So I want to have the interval of all numbers from 8/5 and beyond. We include 8/5 because of the equal sign, so that's the hard bracket up to infinity. Example 7. Distribute the 5 and distribute the 6. Gather the like terms on the left. 4x and 5x make 9x. 12x and -5x equals 7x. Then we're going to subtract 7x from both sides and add 35 to both sides. And we come out with a nice, clean, beautiful number of x equals 11. This is not a fractional answer. Quite nice. Okay. Example 8. This should be getting pretty old and easy to do now. We distribute the numbers, gather together like terms on the left and the right, and we should be alerted here. When I add 5x to both sides, I get the sentence -9 equals -3, which is false. And we know false sentences means there are no solutions to the equation. Finally, example number 9. 3x minus 5x minus 4. We distribute the -5 into the x minus 4, and we distribute the 7. Gather our like terms. The 3x and -5x give us 2x. 20 and 14 gives us 34. And on the right-hand side, we gather the 21 and the -2 to give us the 19x. Then we'll subtract 19x from both sides and subtract 34 from both sides. And we arrive at a solution, after dividing, of a reducible fraction. So, because we divided by a negative, the inequality changed directions. Our fraction, the numerator and the denominator, are both divisible by 3. So I reduced the fraction and then wrote the answer as an interval notation. We want all numbers from -infinity up to, but not including, 23/7. Okay, that concludes the video. Thanks for watching. Be sure to comment, like, subscribe, hit that bell for notifications.